Blindness.
This original Department of Defense film with the original soundtrack explains some of the real-world effects from nuclear detonation flashes.
Light, although not a primary casualty producer, can cause temporary flash blindness to unshielded eyes. In addition, anyone looking directly at a nuclear explosion may suffer permanent eye damage even at very large ranges. Readily visible, day or night, the intense flash of white light is an easy identifying mark of the nuclear burst. No other type of explosion can equal it.
Another film clip explicitly talks about permanent eyesight damage and how to accomplish it.
An example is that a 1 megaton explosion at a height above 130,000 feet can produce retinal burns as far as the horizon on a clear night. The only sure means of negating these effects is to avoid looking at the burst and shielding the eyes.
This is compared to shot orange at nearly the same altitude, well within the reach of almost any short-range ballistic missile. Good luck following the narrator's advice. This will be a surprise to anyone near the detonation. Only random chance will keep someone from not looking in the direction of the burst. These old film clips show everyone putting their goggles on while listening to the detonation countdown. Everyone is calm because they're prepared and know what's going to happen. I've sped the film up to make it more obvious what the goggle donning process looked like. Test shot Teak was shown a few minutes ago. Teak reached its correct 48-mile altitude, but was off target by over 20 miles. Accuracy was a constant problem with test shots, but this put the warhead directly over its launch point of Johnston Island. The shot was at 10:50 p.m. This picture shows the test facilities at that time of night, just before detonation. Scientists and technicians were hoping to see the explosion. I've put this clip in slow motion so you can see that they're all wearing goggles. Being that close was very unexpected, and everyone panicked. Test shot Wrangell produced a yield of only 115 tons of TNT, almost exactly the same yield as the 100-ton test used to calibrate instruments for the very first nuclear explosion. Despite the extremely low yield, this film has the burst silhouetted against the bright sun in the clear desert air, an angle that allows us to see the intensity of the flash. I've put this film clip in extreme slow motion, allowing us to see the incredible brilliance of the burst, even on a device that was a fizzle, since it fell well short of its intended yield. The brilliance of the burst outshines the sun by orders of magnitude. Rabbits were used for animal tests as well as monkeys. Shots Annie, Nancy, Badger, Harry, and Simon purposely exposed a total of 40 people to flash blindness. Recovery varied quite a bit, but was in the range of 3 minutes. After tests and analysis, the safe distance for watching the Teak fireball at night without wearing goggles was 457 miles. Choroid retinal burn in a rabbit's eye. The light from the fireball is so bright that it burns a hole in the retina and into the choroid tissue behind it. Those cells have been destroyed and the eye is unable to repair the damage. Flash blindness happens when all the light detecting pigments are overloaded and bleached out. After a few minutes, the retina is able to recharge and vision returns with no permanent damage. The light pulse happens in less time than an eye blink. Turning your head or covering your eyes with your hands is too slow to have any effect. Off-center exposure to the fireball will still cause burns, but they will be on the periphery of your vision. The burst that's mostly centered in your field of vision will cause serious permanent damage. In all these scenarios, you will be flash blind and also have a burn. Use of goggles with density 4, attenuating the light fluxes by a factor of 10,000, became the rule in tests. In other words, sunglasses, tinted windows, and other common methods of shielding eyes from the glare of the sun are useless. Even welding goggles aren't dark enough, especially goggles that darken automatically. The news gets worse when considering reflections. Specular reflections are the blinding reflections during daylight, leaving green spots behind as an afterimage. These are some examples. Indoors, the brilliant fireball can come through a window, be reflected directly onto your retina. In the case of water ripples reflecting specular light, the risk of terrible retinal burns is obvious. Timing the burst to coincide with rush hour would be an extremely effective method of paralyzing our society everywhere, in the cities, the suburbs, and the countryside. Or it's July 4th and you're watching fireworks, along with millions of other people. These high-altitude bursts also leave very pretty auroras in the sky. Don't look at those if this happens. There's a very good chance the enemy will launch a second and possibly a third strike, and you'll be looking directly at them if they follow the same trajectory. When your vision starts coming back, things are not going to look normal. This will just add to the panic and confusion. The length of this highway collision video clip is only 1.5 minutes. Overall bad weather such as this has mild consequences compared to flash blindness from a nuclear burst. There is heavy cloud cover, fog, falling snow, and snow on the ground. If a nuclear burst happened in this type of weather, the risk of retinal burns is reduced since the light is diffused. Unfortunately, this increases the risk of flash blindness. While watching this deadly demolition derby, imagine how bad a nuclear burst would be. Your vision instantly disappears by going completely white. No worrying of any type, just instant blindness. If you're on the road, you and your vehicle will slam into unseen vehicles, trees, and buildings. Suffering painful, severe injuries are guaranteed in a situation like this. Since the nuke detonated in outer space, there will be no sound of an explosion and no mushroom cloud. During a daytime attack, there will be no auroras and the fireball will dissipate very quickly. No one is going to have any idea what just happened. When the military asked several experts their opinions on what the general civilian reaction would be, these were some of the answers. Shock, going catatonic, freezing in place, unable to move, general panic. These are the 10 chapters in this video series. I will continue to release more videos and video series on this complex subject.